Beyond the deep.
昨天光告诉我在生活吗？昨天光告为了生活吗？
Allah wani emi yauti na fulbe. Sare seneta. Allah hokka da emi yauti na fulbe. Alhaji Shehu Bai.
Welcome once again to Senator Shehu Umar Online Academy or Senator Shehu Umar Mathematics or Science like Engineering related classes. Now, our topic of discussion today is differentiation from first principle, which is also a very important topic for tertiary institution and also SS2, SS3 students. We are going to look at how to differentiate these two x's to power 3 using first principle. Using what? First principle. But before, if you have been following our class, for this method, you are going to make use of the Pascal expansion. That means if you should go back to our Pascal expansion class for better clarification, because the expanding of bracket here, we are not going to do manual expansion. We are going to make the expansion of the bracket to be summary, that is using Pascal method of expanding bracket. Now, if you look at it, this is first principle. They say we should differentiate this equation y equals to 2x raised to power 3 using first principle. Using what? First principle. Now, if you are solving this expression using first principle, first of all, name here to be your right hand side and name here to be your left hand side. Or name here to be your left hand side and here to be your right hand side. If here is our left hand side, we call it LHS. And here should be our right hand side, we call it RHS. Left hand side is y, right hand side is 2SQ. Now we say, since here is y, you now say add the y to the left hand side and the x to right hand side. Here is y, you say y plus the y equals to 2 open bracket x plus the x. Don't forget our x is q, you now put x plus the s cube. If you look at here, if you come down, this is the same thing you are going to have. You are having y plus the y equals to 2 open bracket x plus the x. Since it is true, means you are opening the bracket in 3 places. You now see x plus the x, again x plus the x. Now, if you recall, using our Pascal rule, if you use our Pascal rule, bracket 3, if you remember, we have 1, 1, 1. 1 plus 1, 2. 1. 1 plus 2, 3. 2 plus 1, 3. And then 1. Bracket 1, bracket 2, bracket 3. We are here. This is what we are going to use. Now, you said it's equals to 2 open bracket. Expanding this bracket, you put your x. Since it is power 3, you now put x power 3 plus. You come to your Pascal triangle. After 1 is 3 that come. After 1 is what? 3. You now say plus 3 x. Remember your rule for Pascal. X is power 3 here. It will decrease by 1 to the power 2. Then the x plus. After picking 1 and 3, remain this 3 plus 3. X reduced by 1 based on the Pascal rule, it is x dx squared. The x what? Squared. Then plus the x power 3. This is it. Then you now open the bracket. Open the what? Bracket. You are having 2 times s cubed is 2s cubed. Plus 2 times 3 is 6. But there is x squared dx, you put x squared dx. Plus 2 times 3 is 6. But there is x dx plus 2 times dx, it is 2 dx, but there is what? 2. There is what? 2. If you like, you can call this one equation 1 and you can call this one equation what? 2. You now say subtract equation 1 from equation 2. Look at the right hand side of equation 1. and look at the right hand side of the equation 2. You now say y plus dy. Y plus dy is the right hand side of equation 2. You now remove the y that is the right hand side of equation 1 equals to. You now put all the things we have here as at the right hand side of equation 2. 2x cubed plus 6x squared dx plus 6x dx squared plus dx cubed. Then you say minus 2x cubed minus what? 2x cubed. If you look at it, from the left hand side, y cancel y, plus y cancel minus y. And from the right hand side, 2x cubed cancel 2x cubed, plus 2x cubed minus 2x cubed cancel. Here we are left with dy equals to 6x squared dx plus 6x dx squared plus the x what? Cube. Plus the x what? Cube. You now divide everything by the x. You say all over dx, all over dx, all over dx, all over dx. The x here cancel the x that is here. Then the x here, since we have 2 dx here, cancel 1, remain 1. The x here cancel 1, remain 2. Therefore, our expression will be dy dx is equal to 6x squared. 6x squared, the x, no the x here, it will be 6x squared plus 6x dx, because 1 dx has crossed 1 dx here, remain 1 dx, it will be 6x dx. 6x dx plus dx cube. Dx what? Cube. Since before it was dx cube and 1 dx has crossed 1, remain dx squared. You now take a limit. Limit as the x turn to be 0. Anywhere you see the x now will be 0. Therefore, your dy dx will be equal to 6x squared plus 6x into 0 plus what? 0. 6x into 0 is the same as 0, as 0 is 0. Therefore, our dy dx is equal to 6x what? Squared. This is our final differential value using first principle. This is our final differential value for 2x cubed using first principle. Now, the summary of the explanation is, if you are differentiating y equals to 2x cubed using first principle, you name your y side to be your left hand side and your 2x cubed side to be your right hand side. The statement says the first step is add the y to the terms of what in y and add the x to the term in x. If you go to tertiary level now, this is what we call separation of variable. The term in x will be at the right hand side, while the term in y should be at the left hand side. We call it variable separate. Now, you add the y to here, y will be y plus the y equals to 2. Your 2 comes down, you add the x to the other side, that is the term in x will be x plus dx. Now, y plus dy is equal to 2 open bracket x plus dx cubed. Don't forget, our right hand side, our x is in cube. That means we are opening this bracket in 3 ways. 2x plus dx, x plus dx, x plus dx. You use your Pascal expansion, 1, 3, 3, 1. Therefore, it's the same as 2 open bracket x cubed plus 3. This 3 is 3x squared dx. As you are going, x that is cubed here will be x squared. As x comes down, 3x dx squared plus dx cubed. Therefore, expanding the bracket, 2 times x cubed, 2x cubed, 2 multiply everything inside this bracket, we have what we have here. We name this equation equation 1, as the normal equation given to us was named to be equation 2. Therefore, subtract equation 1 from equation 2. Therefore, after putting all the left hand side of equation 2, you now say y plus dy is what we have at the left hand side of equation 2. You now subtract what you have at the left hand side of equation 1, which is y minus y, equals to, then put all what you have at the right hand side of equation 2, you put it here, minus what you have at the right hand side of equation 1, which is 2x squared, you have it here. Your plus y cancel minus y, your dy equals to your 2x cubed cancel minus 2x cubed, you are left with 6x squared dx, 6x dx squared plus dx cubed, you have it here. You now divide both sides by dx. dy over dx will be this expression. After dividing both sides by dx, you have this. Then you now take what we call a limit. Limit of dy approach 0, or dx approach 0, or dx turn to 0. Dy all over dx will be 6x squared plus 6x. Anywhere you see dx now is 0 and dx also 0. 6x multiplied by 0 is negligible, was neglected to be 0, that is eliminated. 0, you divide everything by it, you have dy dx is equal to 6x squared. This is the differential parameters for 2x cubed using the knowledge of first principle. Now, in our next class, we are going to introduce the many ways of differentiating a particular expression. And differentiation, we have different ways, means of different method of differentiation. There is differentiation by formula method, differentiation by first principle, the quotient rule, the product rule, and the chain rule. But unlike the other method for solving linear simultaneous equation, it is the form of the expression that determines the type of differentiation that is supposed to be used. In our next class, we are going to proceed with differentiation using the other method, either the chain rule, the quotient rule, and the other rules. Thank you.
Together